Good evening, everybody. A little bit later than I wanted, but still, here is the promised walkthrough of the Chapter 5 test prep papers. So, watching some of these are like really easy. Some are a bit more complex. However, the main point of Chapter 5 is understanding vocab. Knowing what the Mid-Segment Theorem is, knowing what the perpendicular bisector theorem and its converse are. All of those things add up. And so really, this is it's really important that you understand what these words are. And I'm not going to go through and spoon food you everything there. I just want you guys to know that a lot of kind of how you approach a question will be determined on whether or not you actually understand, what is the question is asking. So, 1, 2, and 3, we're looking for, actually this goes all the way down to 8. So 1 through 8, lesson 5.1, we're talking about the mid-segment theorem. And the mid-segment theorem states that if you connect, if you draw a line between two midpoints on a triangle, so the triangle is going to have 3 midpoints. Each side has its midpoint. If you connect any 2 of those, you get what's called a mid-segment. And that mid-segment has 2 special properties. It is half the length of the side it doesn't touch. So look at number 1, okay? So number 1, we know that this is a midpoint right here, and this is a midpoint right there. So we connect those 2, we have a mid-segment. Now notice that because it's connecting 2 midpoints, it's not touching a third side. So the resulting mid-segment is going to be half the length and parallel to the other side. So parallel to half the length. So knowing that, we can then say that 7x minus 1 equals 48. Now that smaller amount, that mid-segment, it's going to take 2 of those to equal the big one. The other way we could do this is we could also divide 48 by 2. Now as you notice here, if we divide by 2, we end up getting the same thing. So we get 7x minus 1 equals 24. Add 1 to both sides, and we get 7x equals 25. We're then going to divide both sides by 7, and we get x equals 25 over 7. Okay? Now notice if I plug that back in right there, wrong button, if I plug in that right there, 25 over 7 times 7 is going to be 25. 25 minus 1 is 24. 24 is exactly half of 48. So it works great. Moving on. This next one, we have 48 times 2 equals 3x. 96 equals 3x. Divide both sides by 3, and we get x equals 32. Notice again that 48 is connecting 2 midpoints, so it is a mid-segment, which means it is half as long and parallel to the third side. Number 3. 2 times x equals 14, which means that 2x equals 14 or x equals 7. Now some of you can just look at these and do them in your head. That's great. Remember, for the test, you're going to want to make sure you put down your work. Moving on. So, as we just said, when you have midpoints, see how it says the figure at the right QRS, or midpoints of LMN. We know that each mid-segment is going to be parallel to the side it doesn't touch. So that's number 4 there for you. Now notice here, we're told that LR equals 25, and we need to find QS. Now notice that LR is half of LN. We also know from the mid-segment theorem that QS is going to be half of LN as well, because LR is half, QS is half, 25 equals 25. If I plugged it all in, it'd be the same thing. So, moving on, number 6, MN equals 40, and we want to find QR. So MN is the actual side of the triangle, QR is the mid-segment, which is going to be parallel to and half its length. So half of 40 is 20. Okay, so this next one a little tricky. So we know that that's 53. Now look, we know that QS and LN are parallel lines because of the mid-segment theorem. We also know that if those two are parallel lines, MN right there is going to be a transversal. So this goes back to the last chapter a little bit. So we go, and then we look at those two angles, RNS and QSM. And we see that they're both corresponding, which means that that's going to be 53 right there. We already know that that's 90, which makes angle Q right there, SQM, 143, that's 90 plus 53, plus SQM equals 180, so that gives us SQM at 37 degrees. And that's just, again, that's not technically a mid-segment theorem question, but it does require you to understand that because QS is the mid-segment and opposite LN, that they're going to be parallel. And it's that parallel, those two parallel lines crossed by a transversal that give you what you need to know with the corresponding angles being congruent. So, this next one, so we look at number 8. So when we look at the diagram, we see that we have two midpoints. We know they're midpoints because the top one, 150 on each side, bottom one, 182 on each side. So we know that that is going to be parallel to and half the length of that third side, 280 feet. 280 divided by 2 gives us 140. So the answer there is going to be 140 feet. Now, looking down at number 9, we want to find the value of x. Now, what I just sketched was to show you that the line that goes through D is so GD is the perpendicular bisector of AC. How do we know it's a perpendicular bisector? Because it's got those two little marks that says it's halfway between A and C. And it's got that little mark that says it's a 90-degree angle. Well, we know from the converse of the perpendicular bisector theorem that any point on the perpendicular bisector is going to be equidistant from A and C. So if it's equidistant, then we can go ahead and simply bisector. So we set it up as equal to 2x minus 3 equals x plus 2. You can also treat this as A and C being slight technical difficulty. Should be figured out though. So let's continue. So it is on the perpendicular bisector of AC. Also, you can say that C and A are equidistant because GD is the angle bisector of D, that the distance from GD to the sides of the angle is the same as well. So we're just going to sit there, and we're going to set 2x minus 3 equal to x plus 2. Subtract x from both sides, we're going to get x minus 3 equals 2, or x equals 5. Now that we have x, to find AD, we just plug in 2 times 5 minus 3. So 10 minus 3 is 7. Okay. Now, as I just circled, it's asking for the value of y. Well, what we know is that EG and FG are equal to y plus 5 and 3y respectively. So we look there and we see that BG is the angle bisector of angle B. Now remember, the angle bisector theorem says any point on the angle bisector is going to be equidistant from the sides of the angle. How do we determine how far away a point is from a line? Well, it's the perpendicular segment between the point and that line. So here we see that because G is on the perpendicular, or not perpendicular, but angle bisector of B, then it's going to be equidistant from the two sides of the angle that form B, BE and BF. Okay. So what we do is we set, again, those equal to each other. So we're going to go y plus 5 equals 3y. Subtract y from both sides, divide by 2, and we get y equals 2.5. Now again, to get EG, all we have to do is plug in y equals 2.5. So we get 2.5 plus 5 equals 7.5. Now someone in one of my classes came up to me and said, hey, this doesn't look right because EG is clearly shorter than AD. And yet AD is measured at 7 and EG is measured at 7.5. Not to scale would be what I'd say. So looking now at 13 and 14. So what I'm going to do is I'm going to actually just put up the proofs and kind of talk through them. So here, what the givens say is that all of those lines going upwards from C to P and then downward from C to Q, up from B to P, down from B to Q, up from A to P, down from A to Q. They're all the same. So what that means is that A is the same distance that it is from P as it is from Q. B is just as far away from P as it is from Q. As is C. C is equidistant, that's the word we use. So equidistant from P and Q. So that's why we start off with given. And what does that mean? Well, it means that, and that's that next sentence, that they're all equidistant from P and Q. Now, because they're all equidistant, we can use the converse of the perpendicular bisector theorem to say that, remember, because the perpendicular bisector theorem says that if a point is on the perpendicular bisector, then it is equidistant from both of the segment's endpoints. And the converse of that is if a point is on or is equidistant from both of the segment's endpoints, then it's on the perpendicular bisector. So when we look at A, we can see that A is equidistant from P and Q. P and Q being the endpoints of the given line segment. So we have P and Q, and we know that A is equidistant from those two endpoints. Well, if it's equidistant from those two endpoints, then the converse of the perpendicular bisector says that it's on the perpendicular bisector. Same thing goes for B. Because B is the same distance away from P as it is from Q, it has to be on the perpendicular bisector. Same thing with C. So, because A, B, and C must all be on the perpendicular bisector of PQ, and because each segment only has one perpendicular bisector, they all need to be on the same line, or that they are collinear. Okay. Next one. This one's a little bit trickier, but once you understand it, actually makes more sense. So what we're told is that CX, that's the line segment from point C to point X, is the angle bisector, or is that CX bisects BCM. Well, again, what do we know about angle bisectors? We know that angle bisectors, that if a point is on the angle bisector, then it is equidistant from the two sides. So what we do is we say, well, CX bisects BCM. Well, that means that the point X, because X is clearly on the angle bisector, is the same distance away from both sides at all times. Doesn't matter where on that bisector we put X. So it is the same distance from the side BM as it is from the side BC. And then we just repeat that logic again, because BX is the bisector of MBC, then we know that any point on there, again, is the same distance away from both of our sides. So that means that X is then the same distance from side CN as it is from CB. Well, if it's the same, notice that both angles have BC or CB as a side. So if it's the same distance if it is equidistant from side MB as it is from B to C, as it is from C to N, then it must be equidistant from both. If it's equidistant from both, then the converse of the angle bisector theorem says that it must be on the angle bisector, which then means that X is on the bisector of A, which is what we were trying to prove in the first place. Okay, moving on. So, what is going on here? Okay, so we're given these 2 points, -3, 2, and 7, -5. And we're asked to find the equation of the line that goes through, or the equation of the perpendicular bisector to that line. So, perpendicular bisector, 2 things. Goes through the midpoint at the goes through the midpoint at 90 degrees. So, midpoint, 90 degrees. We find the 90 degree thing by using slope. And so we go y2 minus y1 over x2 minus x1. Notice here that because it's x2 minus x1, but the -3 already has a negative. So when we plug it into that equation, we just get 7 plus 3. Oops. So this is going to give us a slope of 7/10. Now remember, perpendicular slopes are the opposite reciprocals of each other, or the negative reciprocals of each other. You want to take your fraction of a slope, in this case -7/10. You want to flip it upside down and change the sign. So we go from -7/10 to +10/7. We then need to find the midpoint. Midpoint is x1 plus x2 divided by 2 and y1 plus y2 divided by 2. So when we do that, when we plug in these endpoints, because that's what we're looking for the midpoint of this line. Plug in n7 plus a -3 divided by 2, -5 plus 2 over 2. So let's give us 4 over 2 and -3/2. So now we kind of need to rewrite the question, or we can, I think it works, as what is the equation of the line that has a slope of 10/7 and goes through the point to -3.5. What we're going to do is we're going to plug it into point slope form. Y minus y1 equals m times x minus x1. And then we solve for y. Why are we solving for y instead of just leaving it in slope intercept? Because the instructions say to put it into slope intercept. Slope intercept. So when you go from point slope to slope intercept, all you really need to do is solve for y. Sorry, I got a little sidetracked there. Just solve for y. Okay, so here we distribute that 10/7. We're now subtracting 3/2 from both sides. So we're going to go to 14ths as a common denominator. And that's going to give us y equals 10/7 x minus 40 over 14. And that's how you do that. So, on to the next problem. Or minus 61 over 14. And that makes sense. If you look at where that line kind of hits, 10/7 we know to be the right answer. And then 61 over 14 is going to be the intercept. If we look at the graph, it kind of makes sense where it was. So, next up, 16, 17, and 18. It says, find the center of the circle that you can circumscribe about ABC. That is the circumcenter. Now remember, I told you that when you're looking for the circumcenter, on a right triangle, it's always going to be in the midpoint of the hypotenuse. So, quick sketch it, 2, 8, 0, 8, and 2, 2. Now notice here it is a right triangle, so we're looking for the midpoint of the hypotenuse. The endpoints of the hypotenuse are 0, 8, and 2, 2. So just plug it into our formula. And we're going to get 1 and 5. 17, same idea. So we run that through. Same thing. We see that B and C are the endpoints this time. And we get 2, 2. Again, here we have a right triangle. So we're going to plug it into the midpoint formula. And on this last one, 18, we see that the midpoint of it, again, the midpoint of the hypotenuse, which is the circumcenter, which is she can, be anywhere, or that, I'm not sure what I just said. It's 0, 0. Plug it into the midpoint formula. The circumcenter is the center of the circle, which contains all three of the vertices. It is also the point of concurrency of each side's perpendicular bisector. So, when we look at number 19, what is the point of concurrency of the angle bisectors of QRS? Well, here's the thing. When we look at the big triangle QRX, we see that it only has two angle bisectors right there. They intersect at C, therefore that's the point of concurrency. Okay, I'm going to skip 20, mainly because there's really nothing doing there. The answers in the book or the program have the answer as something completely undoable. It's just like a high kind of thing. But so we're skipping it anyway. This is a little bit tough. So now we're talking about Ortho Centers. And what we're looking at is the Orthocenter is the point of concurrence of the altitudes. The altitudes go through a vertex to the opposite side at 90 degrees. So what we're going to do is we're going to start off by looking at that bottom line. It's horizontal, so we know that anything perpendicular to it is going to be vertical. We also know that because they're altitudes, it has to start at the opposite side. So this isn't a perpendicular bisector where it has to go through the midpoint at 90 degrees. This is just from one vertex to the opposite side. So we know that, so we just need the midpoint, because we know that because it's a horizontal line, that anything vertical to that is going to be vertical. And so really all we're looking here, any vertical lines have a equation of like y equals 1, x equals 1, x equals 2. So here, the altitude is going to have an equation of x equals 3.5, because it goes through there, up and down, straight, perpendicular to the horizon. So we then need to find out so we're still doing a, what's it called here? I'm sorry, I thought we were doing an orthocenter. We're still doing a circumcenter here. So it is the perpendicular bisector. So we find the midpoint, we find the slope. With the horizontal line, it's really easy. With a vertical line, or with a slanted line, it's a little bit different. So here we have y minus 11 halves equals 1/5 x minus 11 over 2. So again, what we did is we figured out that the midpoint was 11 halves. We figured out that the slope of the side was -5. So anything perpendicular to that is going to be positive 1/5. And now all we need to do is plug in that x equals 3.5. And when we do that, that's what it looks like. And we get, if you kept it in fractions, you get 7/2, 51/10 as your xy coordinates of the point of concurrency. If you did not, then it was 3.5 and 5.1. So fractions are there and decimal points are there. So we're skipping 22. That was 21 that we just did. And it's important that you understand that where it says find the center of the circle that you can circumscribe about the triangle with the vertices, again, that you understand the definitions of things. And not just, hey, what is the definition of a circumcenter, but that you actually can look at the definition of a circumcenter, which is here, and trace it back. So that knowledge should work both ways. You can either hear the word and know the definition, or hear the definition and know the word. So, a couple things here to remember. That when medians intersect, they do so at the centroid. And that centroid has specific properties. Again, it is the center of balance of a triangle. But for our purposes, more importantly, it is always 2/3 of the way in between the vertex and the opposite side. So it breaks down like the median into this kind of 2/3, 1/3 thing. So we have FH here, right? Because that's the entire median. And L is the centroid. So we know that FL is going to be 2/3 of FH. From the vertex to the centroid is 2/3. From the centroid to the midpoint is 1/3. Okay, so slight issue with my computer decided to do a Windows update. So anyway, back at it. So it's a 2/3, 1/3 issue. So we know that the distance from the vertex to the centroid is 2/3 of the total median, and the distance from the centroid to the midpoint is the other third. So we know that, and we know that 2/3 is twice 1/3. So we know that the distance from the vertex to the centroid is twice the distance from the centroid to the median. Again, knowing your vocab is so important here. So here we're given the HL. That's the distance from the midpoint to the centroid, and that's a half, okay? So that's the 1/3. So we know that the FL, which is the distance from the centroid to the vertex, is going to be twice that. So we got 2 times 30 is 60, okay? 60 plus 30 is 90, and that makes sense. Next one, KE, that is the entire length of the median. So if we break that into thirds, we get 5. That's 15 divided by 5. 1/3, then is 5. 2/3 is 10. Next, DL. That is the distance from the vertex to the centroid, so that's 2/3 of the total median. Well, we also know, as we said earlier, that's going to be twice the remaining side. So that means the remaining side, or the remaining length, rather, is 12. And then we add them together to get the length of the median. 26, 27, 28. Median, altitude, perpendicular, bisector, none of these. How do you know? So again, it has to do with whether or not you understand what these are. So 26, we look and we see that AB connects a vertex to the midpoint on the opposite side. Median. 27. It connects the vertex to the opposite side at 90 degrees. Altitude. And finally, 28. We see that it is at the midpoint, that B is at the midpoint, and that AB is perpendicular to that line. Through the midpoint, perpendicular, perpendicular bisector. Okay, so I started this earlier, but this is actually the Orthocenter part. So those are my 3 points, -1, 0, 0, 4, 3, 0. So the Orthocenter is the point of concurrency of all the altitudes. So again, altitude connects the vertex to the opposite side at 90 degrees. So we already have our point because what we're going to need to do here is we're going to need to find the equations of two of our altitudes and then find out where they intersect. So here, again, we see that negative 1, 0 and that 3, 0, and that's really easy. It's a horizontal line, so anything vertical to that is going to be or anything perpendicular to that is going to be vertical. So we look at the vertex opposite, which is negative 1, 0, and we go, what is the vertical line going through negative 1, 0? And that is x equals 0. Or sorry, 0, 4, and that is x equals 0. So we have our first altitude. Now what we're going to do is we're going to draw a line like that, one of those two, and we're going to find out the equation of that line, and then do some algebra to figure out what our actual answer is. So we know that the slopes of perpendicular lines are opposite inverse of each other. So if we start at negative 1, 0, okay, so we're starting at negative 1, 0, and we're going to find the altitude of that. We get a slope of this side right here, of this side right here as negative 4/3, which means that when we want the perpendicular line through there, we get positive 3/4. So now we've changed the problem a little bit. And we're like, what line is perpendicular to 0, 4, 3, 0 and goes through the point negative 1, 0? So what we do is we plug that into our point slope. And then to find out that point of intersection, we're going to take that 0 right there, because we already figured out that that was the equation of one of the altitudes, x equals 0. And we're going to plug it in to figure out where they both meet up. So we have 0 plus 1, y equals 3/4 times 1, or y equals 3/4. So that gives us a point of 0, 3/4. So 30 and 31, same general idea. What we're going to do is quick sketch a graph. Now here again you can see that there's a vertical line at x equals 2. And so then the line that's going to be perpendicular to that, or the altitude of the opposite side, is going to have to be a horizontal line. So in this case, it's going to be y equals 2. And then what we do is we figure out the slope of the opposite side of one of the points. I'm going to use 2, negative 1. And I find the slope of the opposite side as negative 3/4. Got that by going 2 minus 5. That's y2 minus y1 over 6 minus 2. That's x2 minus x1. So we need the equation of a line with a slope of 4/3 and through the point 2, negative 1. Y plus 1 equals 4/3 times x plus 1. And then we're going to plug that, and that's a 2 right there. Sorry. We're going to plug that 2 in, so we get 3 equals 4/3 x plus 2. going to multiply both sides by 4/3. So we're going to get 9 over 4 equals x plus 2. We're then going to subtract 2 from both sides. Okay. Now remember, 2 as a variable is going to be, or as a fraction with the denominator 4 is going to be 8/4. So it's actually going to give us 9/4 minus 8/4, or x equals 1/4. Now we already figured out our y equals 2. So our answer here to number 30 is going to be 1/4 2. So, number 31. Now, unfortunately, we have no horizontal or vertical lines. So we're going to have to do this one. Just find two different altitudes and figure out where they meet. So I'm going to start by just labeling my points and finding the slope of all three sides. The reason I find the slope of all three sides is it gives me an easy chance to figure out what the opposite slopes are, or the perpendicular slopes. So the perpendicular slope that would go through 4, 0 and be perpendicular to 5, 3 would have a slope of negative 3/5. So what I'm doing first is I'm finding this one right here. Through the point -1, -1, perpendicular to the line containing the points 2, 4, and 4, 0. And to make things a little bit easier, I'm actually going to not just put it in point slope, but actually put it in slope intercept, solve for y. I get y equals 1/2 x minus 1/2. I'm going to do the same thing with the negative 3/5 and the 0.40. So now I have my two equations. Okay? So I have these two equations. Those are my two altitude equations. And I need to find the point of concurrency because that's what this is about. I need to find my orthocenter. So what I'm going to do is I'm going to substitute out the y's. So I end up with 1/2 x minus 1/2 equals negative 3/5 x plus 12 over 5. Now, that's a lot of ugly fractions, so I'm just going to multiply the whole thing by 10 and get rid of all the fractions. So 10 times 1/2, 5x minus 5 equals negative 6x plus 24. Okay, now solve for x. And just so you guys know, you absolutely 100% get the exact same answer. So we're going to add 6x to both sides. We get 11x minus 5 equals 20, or 4. We then add 5 to both sides, and I get 11x equals 29, or x equals 29 over 11. So that's going to be the y-coordinate, or the x-coordinate of where these lines intersect, the orthocenter. So now I can just go ahead and plug that x back into either one of those equations, and I should get the same answer. So plug in 29/11 for x, 1/2 times 29/11 gives me 29 over 22. Minus 11 over 22, that's half, gives me 18 over 22. Or 9 over 11. So 29/11, 9/11 is going to be my orthocenter. And don't worry, nothing like that on the test. But I would like you, even if you're unsure of how to do it, I'd like you to be able to watch it and understand kind of the steps I took to solve that. So 32, ABCD, tell which line contains each point. So really what this is understanding that the circumcenter is the point of concurrency of the perpendicular bisectors. Orthocenter altitudes, centroid medians, and in-center angle bisectors. So we're looking for the circumcenter, so we're looking for a perpendicular bisector. The only perpendicular bisector we have is K. Orthocenter, that's altitudes. Notice, altitude goes from the vertex to the opposite side at 90 degrees. Only one doing that is M. Centroid, that is the medians. That goes from one vertex to the opposite midpoint. So when we look here, we see the only one doing that because the only midpoint we have is on this one right here. So the line connecting the opposite vertex to that is C. Or L. I don't know. Oh, because the C is right there. And then the in-center is the angle bisector. And so we look at the diagram, see the only angle bisected is A. The line doing so is N. So there you go. Triangle inequality. This is not the triangle inequality theorem. It's something a little bit different that we'll get to. But remember, list the sides of each triangle in order from shortest to least. What we talked about was the shortest side is opposite the longest angle. We know that they'll have to add up to 180 degrees. So we can go 180 minus 82 minus 44, or 82 plus 44, 126, subtract 180 and get 54. Anyway, opposite the 44, NR. Next one, the medium angle, 54. Opposite that, RS. And the largest angle, and therefore the largest side, NS. Same general idea here. Not sure what that missing one is. 60 plus 53 is 113. So we end up with 67 degrees as our missing one. So, sorry guys. The shortest side opposite smallest angle. So smallest angle 53 opposite JB. Then PB, then PJ. Finally, that's 90, which means that the other one is going to be 44. Again, shortest across from the smallest angle. QM, QD, and MD. Okay? Now remember 46, 47. What we're looking at here is so we have shortest side opposite shortest angle or smallest angle. So when we name these, when we name R, we're going to pick the two letters that don't get included with R. So 43 was the smallest, next one's up is P. So we're talking about triangle PQR. The two letters that don't have P are Q and R. And then finally we have PQR without Q or PR. Same general idea for 47, except now what we're doing is we're looking for the angles. Okay, same general idea. Shortest side, opposite shortest angle. The shortest side is 5, NS. So NS, again, has to be opposite the letter not being used there. We cross off the N and the S, we get M. So that's how we got M, S, and then N, because it reverses how you look at it. So finally, two sides of a triangle have side lengths 8 and 17. We actually went over this last semester, but if you're doing it, 9 is less than X is less than 25. Also, on the other ones, we're just going to stop there. So we're done. This wasn't the most cohesive thing I've done, but have a wonderful evening, and I'll see you guys tomorrow morning.